Hello everyone, June the 20th. Alright, for this problem, actually I don't want to see the editorial yet. I have some other ideas, right? I have some other ideas. So basically, when we do this, like this, we go 4 ways. I think that's why we're so slow. And we go 4 ways, we try each one of them, and then we'll basically saying we'll replace all the We'll replace all these with something else. Right, we'll replace E and N with the opposite. We'll replace W and N with opposite like that. And we can only do at most K times. So why don't we just go through everything, count how many W and E's are there, right? I count, and I sort this count, and then we're gonna get, the lowest, right? The smallest two, which means if you change those two, you should have the biggest bang of your buck. So that's how I'm going to try. And we'll see if that one works. But before we try that, let's do what we need to do today. Minimum deletions to make string K special. You have word, integer K. Consider a word to be K special if the frequency of one word minus the frequency of another word is smaller than equal to K for all indices I and J in a string. For all indices, so the frequency of a letter minus the frequency, the difference between two letters is smaller than equal to K. Here, frequency denotes the frequency of the character X in word, and this is the absolute value. Return the minimal number of characters you need to delete to make word K special. All right, so we can first do a counter to know what are we talking about. So in this case, we have A, B, C, A, B, A. So we do a counter. A have 1, 2, 3. Oh, this is 8, right? A, B, A. Oh, terrible handwriting. You have 1, 2, 3, 4. B you have 2, and C have 1. And we can sort this, right? We sort this because I want any 2. So what we need to do is the maximum and the minimum, right? The maximum minus minimum is smaller equal to K, then we're good. But in this case, they're not. They're not. And you can delete, right? You delete. So we want a minimal number of deletions so that they'll work. So you can delete, but you cannot add, which means everybody has to, well, we can say, well, converge on C, right? If we converge on C, then this one, if we converge on C, then we know the total, then we need to do, so that's going to be 6 minus 3, we need 3. If we converge on this, so we're going to do 2 and 1, that's still 3. If we converge on this, we still need 3. So is it always going to be the same? So basically we need to converge on some numbers, right? We're going to converge on some number. And so let's say we're going to converge on X. Yeah, depends, right? It depends. Because like we say we'll converge on 4, then everything that's not 4 needs to be deleted. If we converge on 2, then everything now will be deleted. Let me think again. So we definitely can, do a prefix sum. So I think it'll be easier for us to deal. So it's 1, 2, 4, right? So basically we say, well, converge on this value, then it's going to be the sum of this, right, minus, if everybody's 1. So I know the total, I know the sum, so it's 2, it's 6. Actually, it's 6 minus 2. This should be 4. So I need to remove 3. I need to remove 1. Right? So that's actually not. That's 4. And so we'll converge on this, so everybody to the this has to be deleted because we cannot add. And then this will be, 4 minus 2. Right? 4 minus 2 will be 2, and this will be 1, so we have 3. If we convert on this, so it'll be 3. Okay, let's try this one. If it works, then we can get this method. So we have D, A, actually let's go A, B, C, D, right? So D, A, B, D, C, B, D, C, D, C, D, C, D, C, D. So that's 1, 2, 3, 5. Okay? So 1, 2, 3, 5. If we converge on 1, that's going to be 10 minus 3, that will be 7. Converge on 2 will be 8 minus 4 plus 1, that will be 5. Converge on 3, that will be 5 minus 3 is 2 plus, so that will be 5. Converge on 5 will be 6. So the answer shall be 5. Which is not true because k equal to 2. Jesus. Alright, we'll redo it. So the difference cannot be bigger than 2, which is allowed 2, right? So if we converge on this, so everybody should be 3. 3 or smaller, right? 3 or smaller. Oh, so you have to go. I mean, I think binary search will actually make things slower. So why don't you just go through the whole thing, right? I think it will be easier just to go through the whole thing. You'll find it, right? So it's 3. So 3 you can skip. So this will be 2, right? 3 will be 2. If we convert on 2, which means that we can have 5, right? So I need to remove 1. Oh, hold a second. If I converge on 2, then I have 0 to 4, right? 0 to 4. So I check 0 to 4. Okay. If it's within 0 to 4, it's fine. If it's not, so this is not. So then I don't need to get 1. If I remove D, I remove 1D, become 4. Oh, but then this and this doesn't work. Converge to 2. Not converge to 2. We get 2 become the minimum. 2 become the minimum. So everything still has a delete. So that's still 2. 3 is a minimum. I already got 3, so that's not gonna work. So we'll stop doing it. So basically we sort it and then we suppose this is the smallest value, and then we go through the whole thing. Yeah, we can go through the whole thing and see how much we need to add, how much we need to delete. So we get that, and then we do this, and then we do this, and at most is 26. Okay, let's try this. This looks reasonable to me. So basically, what we're gonna do is find the frequencies of all letters, sort it, and then go through the frequencies from small to large. Right. For each frequency, we assume that it is the smallest after the removal, and we count how many removals are needed to satisfy the constraint, and we find the smallest, right, of the removals. it ON because the sorting is really not. So frequency of size 26, char C of word, frequency C minus A plus plus. Is that lowercase letters? All lowercase letters? Yeah. Alright, so we have that, and then we say sort frequency dot begin, frequency dot end. Okay, and for int I, 0 is smaller than 26, I plus plus, right? We also keep a prefix sum, which is going to be interesting. I need a pre-sum, so int pre-sum is 0. Okay, so each time I visit the current one, right, I'll say if frequency I is equal to 0, we just continue. So we don't deal with that. So now we have frequency, the first frequency, right? Then we say for int j equal to I plus 1, j is smaller than 26, j plus plus, right? So we're gonna go through each one of them and check, right? If it's larger, or we can just do the, because the maximum we can get is frequency I plus k. That's the maximum we are allowed. So we do this minus this, because I need to know, what I need to know is, so I also need the result, right? We need the result. We also need something that's put in here. This is removals, right? Removals, okay? And removals. So here, what we're going to do, actually removals shall equal to pre-sum. Remove pre-sum, because everything to the left we have to remove. And then for each one of them, we say removals plus equal to maximum 0 of what current is j, frequency j is what is, minus frequency I, right, and plus k. Frequency I plus k is the maximum that we can allow, and frequency j is the things we want to see, how many we need to remove. And we do this to minus this, tells us how many letters we need to remove for this letter, right? How many letters we need to remove. But if we don't have enough, it's fine. So that's that. And I actually don't need this, right? So we do this, blah, blah, blah. Once we're done, then we can say rest shall equal to, actually no, we can do a check. And let's just do this. We want the minimum, right? Minimum rests and removals. I just realized this has to be like word dot size plus 1. Otherwise it won't work, because I want to find the minimum. And after we've done this, pre-sum need to plus equal to frequency I. All right. This looks about right. Let's give this a shot. Take it for a ride. All right, take it for a ride. It looks possible. Let's try it. Not too bad. Not too bad. 8 milliseconds, 56%. Okay, 8 milliseconds, 56%. All right, let's see. Editorial, hash table, enumeration, hash table to get the count, and we'll get the count. In deleted, which is my removal, is the count. If A larger than B, if A larger than B, delete it. Yeah, this is the prefix sum, right? This is my prefix sum. Otherwise, if b is larger than a plus k, this is this thing. So deleted plus equal to. Eventually we get this. Yep, I think this is about the same. It's actually exactly the same, but they use the map. I didn't use a map, I used this. And I also sorted it, but no, it's 26, size 26. Sorting is pretty simple. And by sorting, I can avoid going back. Actually, I'm not sure. Maybe without sorting, it will be even faster. But I think these are kind of micro optimization. Doesn't really necessary to do that. Okay, so that's that. And let's go back to yesterday. So I have this idea. I want to see if it works. So I'm gonna go to yesterday's. So essentially, it's the same. It will be the same solution, but I just want to try. Maybe it will be faster. Because yesterday is really not fast. It's actually quite slow. It's like hold on, let me delete all this. Yeah, 5%. Right. So I'm gonna try. Let's try another solution. Let's try another way. All right. Another approach. We will keep almost everything, right, the same as solution 1, but instead of going through all 4 possibilities, we first obtain the frequency of each directions, right? And we will identify the 2 directions with the smallest, right, with the smallest count, right? 2 directions with the smallest count, and consider those 2 directions as the one to change, right? This way, this greedy way might work. I'm not sure. Might work, and it only requires us to use get max distance once. Okay, so but instead of doing this, what we're gonna do is we will first obtain do you want to use a map? Why I can use a map? I don't know. What do you think? Yeah, let's use a map. Char int frequency for char c of s, frequency c plus plus. And then what we need is to sort them. I want to find the smallest 2. Like, how do I find the smallest 2 without sorting? We can. We can just say, you know, and actually we don't need the smallest value. Oh, second smallest, damn. Can we hold on? Let me see if maybe there's a way. Can we sort map by value? Exactly. I don't like it. I don't like it. I have to use a pair. That's fine. Let's just use a pair. Vector of pair of int and char. Okay, we need to reverse them. So sorted frequency, right? And for const auto what do we have? We have the frequency and char of frequency. We say sorted frequency dot pushback FNC, and we'll say sorted frequency dot begin, sorted frequency dot end. All right, now we have a first two. Then the direction, like first two needs to be changed because I think these are the directions. We want to go these directions, right? So we need to get opposite direction. So we can say return get max distance, right? So we don't need this S. Now we need the directions for X. Holy crap, I don't even know which one is X, which one is Y. Damn. Char opposite. Oh Lord. Yeah, I don't know if it's I don't know. Okay, X direction and Y direction. And then I say, oh my goodness, if sorted frequency 0 dot second is equal to, oh man, this is so stupid, but I don't know another way though. Actually, you do. I can say it's equal to this, or sorted frequency 0 dot second is equal to north or south, right? If it's north or south, then we can say X direction is going to be opposite of sorted frequency 0 dot second. I still feel very janky. So now the second situation is not, so we can put Y direction, right? Opposite sorted. Hold a second. What if it's like this, the lowest is, oh Lord, it could be, right? The smallest and the second smallest both are, oh my God. Yeah, it is possible. Actually, I have not a big clue. I think we shall find the count of WE, we need to find their counts instead of sorting by them. Yeah, I think I need to find their count directly. Okay, so yeah, I don't think this is right. Sorted frequency, this is not going to be char. This is going to be a string, okay? And then what we're going to do is go through all four of them, right? Go through all four of them and then find their frequencies. So So x first to y second. So possibilities. Actually, I smell another map. Seriously, I smell another map. I feel like we should do another map. We should do another map. Oh my god. Alright, string. But if we do another map, no, then we still need to sort. We still need to sort them. We don't need to sort them. We just need to find the smallest. Okay. If we only need to find the smallest, so we can say there's a frequency of the letter, direction frequency. That's fine. And we can call it frequency of options. Okay. Option frequency. And I think we can just do this. We can say east, north, something. East, south, something. West, north, something. West, south, something. Okay, but of course it's not here. This can be frequency. E, right, plus frequency north. This can be frequency east, frequency south. It's going to be frequency west, north, and the last one is going to be the frequency of west, frequency of south. Okay, so now we have all the frequencies. Then I want to go through to find the smallest frequency, right? So std string main frequency option. Okay, and mean frequency. I don't know, what's the mean frequency? S dot size plus 1, that's the mean frequency. And we say then why you do this? Right? Why you do this? Right? We don't need to do this. We definitely don't need to do this. So we can just say option. We can string option, and then main frequency, right? Actually, we can do this. Option is this. Main frequency is this. Boom, right? And we say if this frequency right, is smaller than main frequency, then we say option shall equal to this, right, and the main frequency shall equal to this, right, and then we just repeat this. If now we're talking about west and north, right, if that is smaller than main frequency, then we say option equal to this, and main frequency equal to this, frequency west plus frequency north, and then if one more time frequency west plus frequency south is smaller than main frequency, then operation equal to west south, and the main frequency, actually I don't even need a main frequency at the end, so I don't need any of this. I do need string operation though. I don't know why I deleted in the first place. Right, so I have all that, and we'll get a minimum, and then we can just return get max distance, we do string, and then we have directions, which is going to be the option 0 and option 1. Oh, let's see. What do you think? This is very greedy solution. I don't have very high confidence that this one passing, but we'll give it a shot. Nope. The minimum change doesn't work. So yeah, it's not this way. Yeah, we tried. We tried, because if we do minimum change for this one, it's gonna be like it can be north, south, NS or NE, right? NS or NE, and you kind of just randomly pick one of these, but you really shouldn't. So yeah, the answer should be SE, right? The answer is SE. Yeah, so NS, SE, and NE, they're all the same. So yeah, this is not going to work. This is not going to work. Even if you pick the maximum, I don't even think that's going to work. Okay, I don't know. Yeah, this doesn't work. This does not work, but it's fine. Let me just delete the whole thing so I don't pollute my mind on this. All right, I guess we do have to read the editorial. All right, we do have to read the editorial. It look very simple though. It look very simple though. I don't know. Well, we'll do this tomorrow. All right, I'll